The last point of stoichiometry that we need to understand is being able to take a substance like baking soda in our rockets and be able to figure out how much product we produce. And in this example, you guys have to know how much gas you're producing to fill your bottle. So, excuse me, these are called mass-to-mass problems. So again, we have to remember that 1 mole is going to be equal to our atomic mass. And then if we're comparing two substances, we always have to look at our balanced equation. Okay, so right here. So we're talking about coefficients here. The coefficients, again, as we balanced our equations, are the large numbers here in front. Those are your coefficients. Those are what become really important when we're looking at comparing one substance in here to another substance. So are they a 1-to-1 ratio? Or are they a 2-to-1 ratio? And we need to look at that as we're converting from one substance to another. So the definition of stoichiometry then is using those mole ratios that I just pointed out from your balanced equation to talk about one compound to another compound. Okay, so we're going to be switching and figuring out how they relate to each other. So let's look at this first example. If we have 4.2 moles of hydrogen, it's going to react with oxygen. How many moles of oxygen are needed for us to have that reaction? So let's start with the given number from the problem like we always do, and it is 4.2 moles. And again, here it's hydrogen, so we need to indicate that it's hydrogen. We are then going to change and try to get to moles of oxygen. So when we do that, we have to look at our balanced equation, and right here we can see that we have 2 moles of H2. And then we need to say what that's equal to. So that's going to be equal to whatever we have for oxygen. So if we look here, the coefficient's 1, so that's equal to 1 mole of oxygen in this case. So this becomes our conversion factor, and we have to plug that in. So we're trying to cancel out our moles of hydrogen, so that one has to go on the bottom, our 2 moles of H2, and then our 1 mole of O2 goes on the top. So our H2 cancels out, we go through, divide by 2, and so 2.1 moles of oxygen is what we have there. So we go back and make sure that that's what we wanted to get to. How many moles of oxygen? That's where we wanted to get, so that one is now complete. So we've taken hydrogen and converted it to oxygen by using our balanced equation and the coefficients there. And this just shows the same thing written out. Okay, so the problem is when we go to lab, we can't measure our baking soda in moles. We're not going to sit there with a microscope and try to look at every little teeny molecule. That would be ridiculous. So what we then have to do is go back and think about our molecular mass is equal to 1 mole. That's easy to do because we just look at the periodic table, okay, and we look up our mass. So let's look at a problem that deals with that. If we have 0.45 moles of silver nitrate, that's our given number here, how many grams of silver chloride is what we're trying to get to. So if we're in moles of silver nitrate, we can go to moles of AgCl because of our balanced equation. So our first conversion factor, you have to look here. Again, we have 2 moles of AgNO3. That's going to be equal to a certain number of moles of AgCl right here, 2 moles of AgCl. So when we use our balanced equation, remember that it's always moles to moles. We have to do that step first. We cannot go from moles of something to grams of something else. We always have to do this middle step using our balanced equation and our number of moles of each. So here we know that our 2 moles of silver nitrate has to go on the bottom, and our 2 moles of silver chloride has to go on top because we want this to cancel out. Okay. So then we go back to our question, and we're not going to stop at moles of AgCl. We want to get to grams. So we know, again, our conversion factor is 1 mole is equal to our atomic mass. And so we can now use our periodic table, and we know we're going to have 1 mole of silver chloride is going to be equal to whatever its atomic mass is. Silver is 108, and chlorine is 35.5. So when we add that up, it's going to be 143.5. So 143.5 grams of silver chloride. Again, atomic mass is always equal to 1 mole. And then we can punch that in. So let's go back down here where it's typed in. It's a little easier to read. So 2 to 2, we cancel this out, and then our 1 mole of AgCl will cancel out our our 2 moles here will cancel out this one. We multiply through, divide by 2, and we get our answer with 2 significant figures because we started with 2 significant figures here. So that's a 2-step mole to mass problem. Now if we're in a lab and we measure something like we're going to be doing, we're going to measure our baking soda in grams, and then we have to get to our carbon dioxide, we're going to have to do a couple more conversions here. So here we're starting with grams of sodium hydroxide. That's our given number. So if we're in grams, again, we have to remember 1 mole is equal to our atomic mass. That's going to be the first conversion factor we use. So sodium weighs 23, oxygen weighs 16, hydrogen weighs 1, and these are all 0.0. So when we add that up, we get 40.0 grams. So we know for 40.0 grams, we have 1 mole, and this is for NaOH. We go back up to our problem. We want to know how many grams of barium hydroxide. So that means we're transferring from one substance to another substance. So we have to go to our balanced equation to get our second conversion factor. So if we look here, we've got 2 moles of NaOH, and that's going to be equal to, we're trying to get to barium hydroxide, 1 mole of barium hydroxide. So that's going to be our next conversion factor. So here we know that our 2 moles of NaOH is going to go on the bottom, and our 1 mole of barium hydroxide is going to go on the top. Okay. Now we go back up, and it's asking for grams of barium hydroxide. So I'm going to go down a screen so we can see a little bit better because I'm running out of room. So we've set up these 2 steps already. Now we look at the mass. We've added up barium plus 2 oxygen plus 2 hydrogen and got 171 it would be 0.4 for us, and we plug that in because we know 1 mole of barium hydroxide is going to be equal to its atomic mass. We plug that in, so now these have canceled out from our previous steps. This is going to cancel out your moles of barium hydroxide. We multiply and then divide, and we get our answer here, 3 significant figures here, 3 here, and that's our 3-step starting with mass. Convert to moles. We have to compare substances mole to mole. That can only come from your balanced equation. And then we convert back to grams for our second substance.